Hi everyone, welcome back to our channel. So let's try to find out the solution for this problem number 32. Is asking us the current in this branch using superposition theorem. The formula here is IL is equal to IL dash plus IL double dash. So in order to do it, I'm going to first step I'm going to find out IL dash. I'm activating 1 volt source is activated and 1 ampere source is deactivated, which is nothing but I have to perform open circuit here. So redraw the same network. So here we are going to make open circuit, and here we are having, and this is the branch where we require. Okay, so the voltage at this point is how much? 1 volt. The voltage at this point is 0 volts. This is of 3 ohm, this is of 2 ohm, and this is of 1 ohm. Okay, so now I want the current in this branch, therefore our current is flowing like this, which is nothing but IL dash. So when you see here, the current IL dash will flow like this, and it will flow only in this branch. So the current doesn't flow in this branch. Why? Because already this is open circuited. So therefore, how I can write down IL dash is equal to, so voltage. Okay, so now current is flowing only in this direction to what I have been shown. IL dash is equal to 1 volt minus 0 volts divided by R. R is how much? 2 plus 1. So that is equal to 1 by 3. So when you, this is the value of 0.33 amperes is the current. Okay, so which is flowing in counterclockwise direction, in counterclockwise direction. Okay, now let's try to solve it. I want to find out IL double dash. 1 ampere source is activated and 1 volt source is deactivated. Okay, so if you redraw the diagram, so this is activated, 1 ampere source is activated, and another source is deactivated. Okay, if this voltage is deactivated, is 0 now. So this is 3 ohms, this is 2 ohm, this is 1 ohm, and this is 1 ohm, and total current given is 1 ampere. And now we need to find out the current IL double dash. Okay, so the current which is flowing in this direction, which is nothing but IL double dash, we need to find out. So how to find out is, so you can see here IL double dash I'm going to find out by two methods. Method one is like this. Okay, so I want the current in this branch. Okay, what is the total current? So total current is how much? So this I'm going to solve by using current division rule. So IL double dash is equal to, total current is how much? 1 into total current is 1. So in this branch I require, what is the branch in parallel to this one? 1 divided by 1 plus, these two are, sorry, whenever this is shorted, there's no need of this resistor. So automatically we can see here, there's no need short circuit parallel to a resistor. So this will also act like an short circuit. Okay, so if we use this basic concept, so IL dash is equal to, total current is 1, and opposite to this is nothing but 1 divided by 1 plus 2. Okay, so if you solve it, which is nothing but 1 by 3 is once again the same, which is nothing but 0.33 amperes. This is by method 1. If you get any doubt, so we will mark this as, and let's try to do it by method 2. So by method 2, here we will mark this as a node, some Vx. Okay, now let's try to find out the value of Vx. So this is the current entering the node, and this is the current which is already leaving the node, and I am assuming the current is also flowing in this direction in the three branches. So already now we are going to apply nodal analysis at Vx node. So what are the entering currents? This black color one, 1 ampere is entering, and what are leaving? So one current is leaving. Okay, so there is nothing but this current IL double dash plus the current which is flowing in this branch, mark with some I1, mark this current as some I1. So 1 is equal to, how to write down IL double dash? So I can write down it as Vx minus 0 divided by 2 plus, how to write down I1? Vx minus 0 by 1. When you solve it, so 1 is equal to Vx by 2 plus Vx. So 1 is equal to Vx of 1 by 2 plus 1. So Vx is equal to, when you solve it, you are going to get it as 0.66 volts. But I require IL dash. Okay, so IL double dash is equal to Vx minus 0 divided by 2. Okay, so 0.66 divided by 2, which is 0.33 amperes. Okay. So when you see these two sources, one current is flowing, so IL, one current is flowing in clockwise direction, and another current is flowing in clockwise direction. Both are in opposite. Therefore, here you will get an negative symbol. Okay, why? Because one is in counterclockwise. In this source, you can see here it is flowing in this direction, but in this source it is flowing in this direction. Therefore, IL dash is 0.33 minus 0.33. Okay, so total load current is 0 amperes. This is how to solve the problem when more than one source is given in the problem. So those are unable to understand why this 3 ohm resistor was previously there. No, why I have it removed is, so these two are in parallel. If you find R equivalent also, then you will get 3 into 0 divided by 0 plus 3. The answer is 0 ohm, where it is also equal to an short circuit. Since it is equal to an short circuit, there is no need of this resistor. So that's why this resistor is removed, and successfully we have been find the answer. Hope you are able to understand the problem. If you feel the way I explain and the way of solving the problem is good, please like the video and please share with your friends. And if you have any doubts, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel. This is a free channel for the development of students as well as faculty. So we'll meet in the next video. Yours obediently Ram.